Learning mathematics is very, very difficult to many people, second only to learning how to speak English. Do you have difficulty? Don't be embarrassed. It's a lot of people don't know what they're doing when they get up there and do their mathematics. We're going to introduce you today to Fort Bend tutoring, honey. Personalized math tutoring is the solution.
Hello ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about partial fractions. That's right, partial fractions. The concept of partial fractions can be found in some pre-calculus classes and definitely in calculus classes, but the whole point of it is to work backwards from a result. That is, let's say that you're looking at a fraction like 5/6. What partial fractions allows us to do is to be able to go back to the original form of the problem where they had more than one fraction combined together. For instance, that 5/6 was originally 1/3 plus 1/2. Okay, now you can do that with more complex rational expressions, like in part B here, where I have 1 over x squared plus 5x plus 6. Partial fractions allows us to find out that this was originally 1 over x plus 2 minus 1 over x plus 3. So the beauty of partial fractions is not only that it's a kind of a time machine where it can work itself back to the original form of the problem, but it also allows us to evaluate these types of functions easier, as well as integrate rational expressions like this by breaking them down into their simpler forms. Okay, so that's what partial fractions is all about. Now let's look at some rules here. When you're dealing with partial fractions, for every distinct linear factor, in other words, in every denominator where you may have a linear factor in the form of ax plus b, your result must include the term a over ax plus b. All right, and if it's a repeated term, you'll have that beginning term all the way up to the highest degree. And then the second thing to keep in mind is that for every distinct quadratic factor in the form of ax squared plus bx plus c, the result must include the term ax plus b over that quadratic factor. All right, and if it's a repeated factor, the same thing applies, that you would have this first factor as well as every other iteration of that all the way up to the highest degree. So that, ladies and gentlemen, is going to be the premise of what we're going to be doing. However, rules are just rules until you see it, right? So let's go ahead and look at some examples. In problem number 1, we have the rational expression 3x over x plus 2 times x minus 1. Well, if you notice here, the denominator has already been factored for us, and each of these factors are linear factors. That's right. If I were to graph by itself x plus 2, then that's going to be a line, whereas the same thing would apply to x minus 1. So these are linear factors, aka your highest exponent is 1 inside of the parentheses here. Well, that means that for every distinct linear factor, remember, we'll have to have a term in the form of a over ax plus b. So my initial setup will be a over x plus 2 plus b over x minus 1. So notice that because each of these factors are distinct linear factors, I have my variable a over the first factor, which is x plus 2. Then I continue on to the next letter in the alphabet for my second linear factor and make it b over x minus 1. Since none of these factors repeat, that's all I need for my setup. So now we're concerned about actually solving this, right? We need to find out what the value of a is. We need to also find out what the value of b is, which means that you will be multiplying each and every term by the common denominator, which is x plus 2 times x minus 1. So let's continue. We'll have x plus 2 times x minus 1 times 3x over x plus 2 times x minus 1. Then on the right side of the equal sign here, I'll be multiplying each of these terms also by the common denominator, which is x plus 2 times x minus 1. So I'll end up with x plus 2 times x minus 1 times a over x plus 2. Then I'll have, in addition to that, x plus 2 times x minus 1 times that last term of b over x minus 1. All right, so this is my initial setup. All right, and yes, it's a little busy right now, but that's because I'm multiplying each and every term, and I wanted to show you by the lowest common denominator, which is x plus 2 times x minus 1. That being the case, here comes the fun part. We'll get to simplify, right? So on the left side, the x minus 1s and the x plus 2s will cancel out to leave me 3x. This equals 2. On the right side here, the x plus 2's will cancel out to leave me with a times x minus 1. Then, in addition to that, I'll be able to cancel out that x minus 1 in that last term, and that leaves me with b times x plus 2. All right, so all of that's simplified to what we have before us now. The next thing you'll want to do is distribute the a and the b. So I'm going to get my arrows popping, ladies and gentlemen. That's right, get these arrows popping. Distributive property in the house. So we'll end up with 3x equals to ax minus a plus bx plus 2b, like so. All right, that's an ugly b, right? Okay, let me fix it. Okay, that's a little better. That's a little better. Yes, it's our art, but we're going to be okay. So that being the case, ladies and gentlemen, what you want to do next is combine your x terms together as well as the constants together, and it'll look like this. I'll have 3x equals to ax plus bx minus a plus 2b. All right, so that's what I have thus far. Let's go ahead and take this part to the next page. So once I have the x terms grouped and the constants grouped, go ahead and factor out your x. So I'll be going ahead and rewriting this as x times a plus b, and then I'll just bring down the constants, negative a plus 2b. Okay, so once we have this, ladies and gentlemen, please recognize that on the left side of your equation, this could actually be written as 3x plus 0 equals to x times a plus b minus a plus 2b. All right, so this is what we have thus far. From here, ladies and gentlemen, you want to look at your like terms on either side of the equal sign. For instance, I know that I have an x term here and an x term here, correct? And I also know that I have a constant 0 here and I have a constant negative a plus 2b on the right side. In other words, this value is not attached to the variable x. Therefore, I'll be able to set up a system of equations at this point. The system will be a plus b equals to 3. Focusing on the coefficients of our variable x, I've written a plus b equals to 3, which is the first equation. The second equation will have negative a plus 2b, and that equals to 0. All right, so here I have a system of linear equations, and since I have this already set up, all I have to do from here is simply solve the system to find out the value of a and to find the value of b. That means that you could use the substitution method or the elimination method, but my favorite, is the addition method, the elimination method. So I'm going to go ahead and cancel out these a's here, and I have 1b plus 2b, which gives me 3b, and so solving for that, I have 3b equals to 3, and then I'm going to divide both sides by 3. All right, so I find that b equals to 1. All right, that's good news. Now that I know what b is, we can go ahead and substitute that back into one of the original equations here, that a plus b, for instance, equal to 3, and find out what our value of a is. So here I'll have a plus 1 equals to 3, and I'll subtract 1 to both sides, and that tells me that a equals to 2. So now we've found that a equals to 2 and b equals to 1. So from our setup, we know that our answer will be in the form of a over x plus 2 plus b over x minus 1. So that means that we can write our solution as 2 over x plus 2 plus 1 over x minus 1, and this is our partial fractions. If you were to add 2 over x plus 2 plus 1 over x minus 1, you would end up with your original form of the expression. All right, and that's going to be problem number 1 done. Let's go on to problem number 2 now. In problem number 2, we have x minus 4 divided by x squared times x minus 1. Remember that for every distinct linear factor, you'll have to have a term of the form a over x plus b. And here, this first factor of x is squared. It's a repeated linear factor. So this is what your setup is going to look like. You'll have a over x plus b over x squared. So since this first factor is a repeated linear factor, you'll start out with x to the first power, and then you'll go all the way up to x to the second power. If that had been x cubed, we would have had another term that would have read c over x to the third power. So we start each repeated factor to the first power, and we climb all the way up to the highest exponent that's shown in the original problem. We also must keep in mind that we have the factor x minus 1. So I'll have c over x minus 1, and this is going to be my original setup right here. All right, so on the right side of the equal sign, I'm showing that I have a over x plus b over x squared because of that repeated linear factor, plus c over x minus 1. So what we'll do from here is multiply each and every term in our original equation by the common denominator of x squared times x minus 1. So let's check that out. So multiplying everything by the common denominator of x squared times x minus 1, we'll do the following here, and I'm going to go ahead and just simply write this way. All right, instead of writing each and every term out, I'm going to go ahead and see if I can write this out in this form, so you'll see that I'll be multiplying each and every term by that common denominator of x squared times x minus 1. All right, so let's do this. So distributing this x squared times x minus 1 to each and every term in our equation here, the first term, the x squared times the x minus 1, will cancel out to leave us with x minus 4. All right, then multiplying x squared times x minus 1 times a over x, one of your x's will cancel out to leave you with ax times x minus 1. Then multiplying b over x squared times x minus 1, the x squareds will cancel out to leave you with b times x minus 1. All right. Then multiplying c over x minus 1 times x squared times x minus 1, the x minus 1s will cancel out to leave you with c x squared. All right, just like that. From here, what we'll be doing is multiplying everything out on the right side. So I'm going to distribute. I got my arrows popping, ladies and gentlemen. Okay, so I'm going to be bringing down this x minus 4, which is equivalent to ax squared minus ax plus bx minus b plus cx squared. So notice that we have x squared terms, x to the first power terms, as well as constants, in other words, x to the 0 power terms. All right, so on the left side of my equal sign, I'm going to show that I have 0 x squared plus x minus 4, which is going to be equivalent to, and I'm going to go ahead and group my x squared terms together as well as the other terms. I'm going to have ax squared plus cx squared minus ax plus bx minus b. All right, so that's what I have thus far, and I hate that b. Yeah, I know you hate that b too. Let's fix the b. Let's fix the b. No, the b is still ugly. All right, the b. All right, that's going to be my b. We're going to stick with that b right there. Okay, so continuing on. From here, we're going to factor. I'll have 0x squared plus x minus 4 equals to x squared will be times a plus c plus x times negative a plus b, then minus b. All right, just like that. With this, we'll be able to write a system of equations. All right, so let's check it out. Okay, so from here, we can start by using the coefficients on our x squared, x to the first power, and x to the 0 power terms to create a system of equations. The first one will be a plus c equals to 0. We'll also have negative a plus b equals to 1, and then we'll also have negative b equals to negative 4. All right, and I'm getting all of that by lining up those like terms. In other words, the x squared terms are together here, and I'm also lining up the x to the first power terms together, and then finally I'm lining up our constants negative 4 and negative b here. Okay, so that being the case, we end up with this system, and lo and behold here, all we have to do to solve for b is just divide both sides by negative 1, right? So we find out that b equals to 4. All right, so we already got one down. In order to find out your a value, you're going to be plugging in b into the second equation here. So I'll have negative a plus 4 equals to 1, and then solving for this, we end up with negative a equals to negative 3, and then dividing both sides by negative 1, you find that a equals to positive 3. Now that I know that a equals to positive 3, we'll be plugging that value into the first equation to solve for c. So this is going to be 3 plus c equals to 0, and this allows us to find that c is equivalent to negative 3. So with these values, a, b, and c, we can write our result as 3 over x plus 4 over x squared minus 3 over x minus 1. This is the result of finding the partial fractions of our original expression. Done and done. That's it. That's all you had to do. That's problem number 2. Okay, in problem number 3, we have x squared over x minus 1 squared times x plus 1. So once again, we find ourselves with a repeated linear factor. So I'll have a over x minus 1 plus b over x minus 1 squared plus c over x plus 1. Okay, so once again, you always start your repeated linear factors with that factor to the first power, and then you'll need to repeat that for every exponent after 1 that you have. So in this case, since I had x minus 1 squared, I needed my x minus 1 to the first power, and then I needed to show that I had x minus 1 also to the second power as well. Since our x plus 1 was just by itself is to the first power, we only needed this one term to represent it. So we have c over x plus 1. From there, we'll be multiplying each and every term by the common denominator, which is x minus 1 squared times x plus 1. We'll be multiplying the first term here, this x squared over x minus 1 squared times x plus 1 times itself, which will leave us with x squared. All right. From here, multiplying our first term on the right side of the equal sign times that x minus 1 squared times x plus 1, one of the x minus 1s will cancel out to leave us with a times x plus 1 times a minus 1. All right. Then multiplying b over x minus 1 squared times x minus 1 squared times x plus 1, the x minus 1 squares will cancel out to leave you with b times x plus 1. All right, and then multiplying our lowest common denominator times our last term of c over x plus 1, the x plus 1s will cancel out. So I'll have c times x minus 1 squared as our last term here. Okay, so this is what we have thus far, ladies and gentlemen, and multiplying our original setup by the common denominator of x minus 1 squared times x plus 1. Now you'll want to multiply the entire right side of the equation. So starting out, I'll bring down my x squared equals to a times this x plus 1 times x minus 1 is going to be a difference of 2 squares, so that's x squared minus 1. Then I'll get my arrows popping, so I'll have b times x, which is bx, and then this is going to be b times 1, which is b, and then I'll have a positive c, and then distributing the expanded form of x minus 1 squared, in other words multiplying x minus 1 times x minus 1, you'll have x squared minus 2x plus 1, like so. All right. Then I'm going to continue to distribute, so I'm bringing down my x squared term, which equals to distribute that a in there, get those arrows popping. Go ahead, distribute that c over there, get those arrows popping again, and you'll henceforth have ax squared minus a plus bx plus b plus cx squared minus 2cx plus c. Okay, and this is what we have thus far. Once again, you want to group your like terms together, so that's exactly what I'll do. I'll be bringing down this x squared, which equals to ax squared plus cx squared. I'll then have bx minus 2cx. Then I also have negative a plus b plus c. All right, so I'm going to show all my terms now. I have x squared plus 0x plus 0 equals to, factoring out x squared from the first two terms, you'll have a plus c. Then I'll be able to factor out an x from the next two terms, which leaves me with b minus 2c. And then finally I have this minus a plus b plus c. So my system of equations will be a plus c equals to 1, b minus 2c equals to 0, and negative a plus b plus c equals 0. What I'll be doing from here is I'm going to take this middle equation and I'm going to solve for b. That will tell me that b is equivalent to 2c, right? Once I have that, I'll be plugging in 2c in for b in the third equation. So this becomes negative a plus 2c plus c equals 0, which tells me that negative a plus 3c equals 0. All right. Now, knowing that a plus c equals to 1 and negative a plus 3c equals to 0, I'm going to combine these two equations, and that gives me a result of a plus c equals to 1 and negative a plus 3c equals to 0. All right. So notice that the a's will cancel out, right? So that gives me 4c equals to 1, and then if I divide both sides by 4, you'll end up with c equaling to 1/4. Okay? So I now know that my c value equals to 1/4. To find out what b equals to, we can plug this in here. That'll be 2 times 1/4, and we'll find that b equals to 1/2. Next, we can plug in 1/4 into our first equation here. And so we have a plus 1/4 equals to 1, which tells us that a equals to 3/4. All right, so now we have our three values, that a equals to 3/4, that b equals to 1/2, and that c equals to 1/4. So I can go ahead and write my result, which is going to be the following. All right, one form of your answer is going to be 3/4 over x minus 1 plus 1/2 over x minus 1 squared plus 1/4 over x plus 1. So this is one of the forms of your answer. Another way to write your result is to place this 4 here in front of the x minus 1 in the denominator. So that first term could be rewritten as 3 over 4 times x minus 1 plus 1 over 2 times x minus 1 squared plus 1 over 4 times x plus 1, which is also another form of the answer that you can submit as well. All right, so there you have it. Done and done, ladies and gentlemen. That was problem number 3. For problem number 4, we have 1 over x plus 1 times x squared plus 4. Okay, so my setup is going to be just like this. I know I need a term for my linear factor of x plus 1, but since this second factor is a quadratic factor, the highest degree in that second set of parentheses is 2, so that's quadratic. So I'll end up needing bx plus c in the numerator over x squared plus 4. So notice how your variables are always in alphabetical order no matter how many you need, but because the second factor is quadratic, we had to have a linear numerator. In other words, we had to have the bx plus c in the numerator. So that being the case, all three of these terms here in this equation, this is all one equation here, we'll be multiplying that by the common denominator of x plus 1 times x squared plus 4. All right, so let's check it out. Multiplying x plus 1 times x squared plus 4, we'll be left with 1. All right, so multiplying the common denominator of x plus 1 times x squared plus 4 times our first term on the right side, which is a over x plus 1, the x plus 1s are going to cancel out. So that leaves me with a times x squared plus 4. Okay, then I'll be multiplying our last term here by x plus 1 times x squared plus 4. The x squared plus 4s will cancel out, and so I'll have x plus 1 times bx plus c. All right, just like that. Okay, so now we'll be multiplying everything out at this point. So I'm about to get my arrows, you got it, popping, ladies and gentlemen. Okay, so go ahead and distribute everything. All right, so just multiply everything out and we'll see what happens. From here we'll have 1 equals to ax squared plus 4a, and then we'll have a term that is bx squared plus cx plus bx plus c, just like so. All right, now grouping all of your like terms together, we'll have 1 equals to ax squared plus bx squared plus bx plus cx plus 4a plus c. And so now we'll go ahead and factor out those variables. So on the right side, I can factor out the x squared to leave me with a plus b. I'll then factor out an x that leaves me with b plus c. And then I'll be left with 4a plus c to finish up that right side of the equation. So now we'll go ahead and write our system of equations. Before we write our system of equations, I'm going to go ahead and show that I have 0x squared terms plus 0x, and then I still have that positive 1 there. The system will read as a plus b equals to 0 because our x squared terms, all right, you're just writing down the coefficients from each. We have a plus b for the x squared term, and we have 0 for this x squared term on the other side of the equal sign. So that's our first equation. Then I'll have b plus c for the x to the first power term, and notice that I have 0 for the coefficient of the x power term here on the left side of the equal sign, so this equals to 0. Then you'll have 4a plus c, and this equals to positive 1, and this is what I have thus far. Okay, just like that. Now, solving our system of equations here, I'm going to go ahead and rewrite this by solving for a in our first equation. So that means that once I solve for a, I'll end up with a equals to negative b. So knowing that a equals to negative b, I'll be plugging this value into this last equation here to rewrite this as 4 times negative b plus c equals to 1 to give me a result of negative 4b plus c equals to 1. So now I'll take this second equation and this rewritten equation here. So taking these two equations here, I'm going to go ahead and solve for my b variable. So I'll need the opposite of this first equation here in order to cancel out my c's. So I'll write it as negative b minus c equals 0, and then I'll have this equation negative 4b plus c equals to 1. From this point, I can cancel out the c's, and I'll have negative 5b equals to 1. And when I divide both sides by negative 5, we'll find that b equals to negative 1/5. All right, so that is my value of b. Remember that the opposite of b is our value of a. So that means that my a value is equivalent to positive 1/5. Okay, and then to solve for c, remember we have b plus c equals to 0. So for that to equal to 0, my c value also has to be the opposite of my b value. So that means that c equals to 1/5 as well. All right, so seeing that we have our value for a, b, and c now, our result is going to be as follows. We'll have 1/5 over x plus 1 plus a negative 1/5 x plus 1/5 all over x squared plus 4. So once again, this is a form of the answer, but if your teacher wants you to clean it up a bit, you can do just that by placing the 5s in the denominator here. All right, as a matter of fact, I'll show you what that looks like. So you could rewrite it as 1 over 5 times x plus 1. And then you could even factor out a negative 1/5 from this. So this will be minus x minus 1 over 5 times x squared plus 4. Okay, so that's another form of your answer. So depending on your teacher, either form of the answer will be acceptable. So it could be written this way, or you could write the answer like that. So ask your teacher which form of the answer is going to be acceptable for your class. Done and done. All right, that was problem number 4. In problem number 5, I have 2x plus 4 divided by x cubed minus 1. So the first thing you'll want to do in this particular problem is factor the denominator. It needs to be factored. It's a difference of cubes. So that means that this is equivalent to 2x plus 4 all over x minus 1 times x squared plus x plus 1. Okay, so it looks like this. Keep in mind that your factors must be factored completely, and that is exactly what we have right here. This linear factor of x minus 1 cannot be factored any further, and your quadratic factor of x squared plus x plus 1 is prime, so you cannot factor that any further as well. That means that my setup for this problem is going to include a over x minus 1 plus bx plus c over x squared plus x plus 1, just like that. Okay, so this is going to be my setup for problem number 5. That means that I'll be multiplying each and every term here by the common denominator of x minus 1 times x squared plus x plus 1. So that's going to be the result of my next step, me multiplying each and every term by the common denominator of x minus 1 times x squared plus x plus 1. All right, so multiplying the LCD times our first term, you'll be left with 2x plus 4. All right, multiplying our next term, a over x minus 1 times the x minus 1 times x squared plus x plus 1. Yeah, the x minus 1s will cancel out, and I'll have a times x squared plus x plus 1. Then, for this last term, multiplying the common denominator of x minus 1 times x squared plus x plus 1 times this bx plus c over x squared plus x plus 1, the x squared plus x plus 1, say that 10 times fast, will cancel out. So I'll end up with x minus 1 times bx plus c. All right, just like that. Okay, from here, we're going to be multiplying. So that's right, get those arrows popping. All right. So over here I have a binomial times a binomial. All right. So next we'll be bringing down 2x plus 4, which equals to ax squared plus ax plus a plus bx squared plus cx minus bx minus c. All right, so this is what I have after I distributed everything. From here, you want to group your like terms together on the right side of the equal sign. So I'll have 2x plus 4 equals to ax squared plus bx squared plus ax minus bx plus cx plus a minus c. All right. Then we'll be factoring out our variables as well as showing all of our terms that may be missing on the left side of the equal sign. So I'm going to rewrite this as 0x squared plus 2x plus 4 equals to x squared times a plus b plus x times a minus b plus c plus a minus c. All right, so this is what I have after I factored out my variables there. And notice how these will all line up. So the x squares will line up with the x squares, the x to the first power term will line up with this term right here, and then my 4 will line up with the a minus c. All right, let's write the system. All right, setting up our system, we'll end up with a plus b equals to 0, a minus b plus c equals to 2, and a minus c equals to 4. All right, so this is what we have as far as our system is concerned, and we want to set this up. So that being the case, we'll go ahead and combine these last two equations here. All right, and the result of that is going to be 2a. My c's will cancel out. This will be minus b, and this will equal to 6. All right, so from here, I'll be utilizing this result as well as the first equation to solve for a. So this is going to give me a plus b equals to 0 and 2a minus b equals to 6. So what happens is my b's will cancel out. I'll now have 3a equals to 6, and then I can divide both sides by 3 to find out that a equals to 2. Now that I know that a equals to 2, we can plug that into our first equation here, and if a plus b equals 0, then that means that b has to be negative 2, right? So b is negative 2. All right. From here, we want to solve for c. It tells us that in the third equation that a minus c is going to equal to positive 4, right? So that means that c has to be a negative 2. That's the only way that's going to work. 2 plus 2 is 4, right? So therefore, we know that c equals to negative 2. Done and done. All right, and so you can substitute those values in and solve for these variables like so. All right, so my answer can be written as 2 over x minus 1 plus negative 2 x minus 2 all over x squared plus x plus 1. You could simplify this by factoring out a negative in the numerator if you want, and you could rewrite it as 2 over x minus 1 minus 2x plus 2 all over x squared plus x plus 1 if you want to write it that way. All right, but depending on your teacher, either form of the answer should be okay. All right, so there you have it. 2 ways to write the result. Done and done. And that was problem number 5. All right, in problem number 6, we have x squared plus 2x plus 3 divided by the quantity of x squared plus 2 squared. So what we have here is a quadratic factor squared. In other words, we have a repeated quadratic factor. So what you want to do when you set this up is the following. You want to have the first one set up as ax plus b over x squared plus 2 plus cx plus d all over x squared plus 2 squared. Okay, so remember, whatever your highest exponent is, if you have a repeated factor, you start out with the first power and you keep going up until you reach that highest amount that you have as an exponent. Okay, so this is our setup for this problem. That means that I'll be multiplying each and every term here by the common denominator of x squared plus 2 squared. I'm going to multiply that to all three of these terms here to simplify it. All right, that being the case, x squared plus 2 squared is just going to leave me with a numerator, which is x squared plus 2x plus 3. All right. Then multiplying x squared plus 2 squared times the term ax plus b divided by x squared plus 2, I'll end up with 1 x squared plus 2 times ax plus b. All right. Then multiplying our x squared plus 2 squared common denominator times the cx plus d over x squared plus 2 squared term, you'll be left with cx plus d. All right. Just like that. All right, from here, you want to go ahead and multiply this out. That's right, distribute. In other words, get those arrows popping, okay? Get those arrows popping, all right? So I'm going to be bringing down the x squared plus 2x plus 3 equals to ax cubed plus bx squared plus 2ax plus 2b plus cx plus d. All right, just like that. From there, ladies and gentlemen, you need to know that you have 0 x cubed terms plus an x squared term plus 2x plus 3, which equals to ax cubed plus bx squared plus 2ax plus cx plus 2b plus d. Okay. So now you're going to factor out your like terms here. So I know that I have 0x cubed plus x squared plus 2x plus 3. And this is going to be equivalent to ax cubed plus bx squared plus x times 2a plus c plus 2b plus d. All right, so that's what we have thus far. Let's go ahead and write our system of equations now. Okay, writing our system of equations, we're going to start out with the x cubed term. And it says that a is going to equal to 0. All right, so my coefficient on the x cubed is a, and that lines up with 0 being the coefficient of the x cubed term here on the left side of the equal sign. Then moving on to the x squared term, I know that b will equal to 1. All right, then moving further, we have 2a plus c has to equal to 2, looking at that x to the first power term. And then finally, I have 2b plus d has to equal to 3. Okay, so this is a scenario. I already know what a is, I already know what b is, and so to find out what c is just going to have to equal to 2, remember, because a equals to 0. So we know that c equals 2. All right, so that's already 3 out of the 4 variables already solved for. And now to solve for d, we can plug in 1 for b to find out that 2 plus d equals to 3. So solving for that, you'll end up with d equaling to 1. So here we have all 4 values solved for. So now we can write our answer, which is going to be 0x plus 1 over x squared plus 2 plus 2x plus 1 over x squared plus 2 squared. And this is the answer right here. Done and done. So remember, we're plugging in the a, the b, the c, and the d value back into this form right here. And because that a value was 0, we didn't have an x term in that first numerator. So we just plugged in our b value, the c, and the d value here over our denominators, and that was our result. Done and done. All right, so that's problem number 6, ladies and gentlemen, and that concludes our lesson today over partial fractions. Hopefully this helped you out tremendously, and as always, please rate, comment, and subscribe. This is Mr. Witt with Fort Bend Tutoring, and if you're able, please donate. Peace.
We certainly hope you enjoyed today's presentation by Fort Bend Tutoring. Did you understand the program? Would you like to rate us or give us some feedback or subscribe to us? Leave a nice comment. Don't just leave something ignorant on there. If you didn't understand the lesson, ask the professor to explain it for you. Don't just get mad and write something ignorant on there.